All right, so I have a question for you. So you can see here log of b at base a is c. So now I want you to tell me what is b here. Can you guys tell me what is b?
Maybe it's referred to basic acidity or base.
No. This is nothing to do with acid or base. I'm just showing the general expression for logarithm. So again, so this is log of b at base of a is c. Okay, so I just want you to refresh your knowledge about logarithm, because if we want to understand what is pH, we need to understand what is the logarithm. Okay, so I believe you studied this at some point, but maybe you don't remember, so you need to refresh this knowledge. Okay, so I just numbers, this is b, this is a, just general expression of logarithm, and we need to understand this, right? So if we have logarithm of b at base a is c, it means that b is going to be a in power c. Okay, do you guys follow or not?
Yeah, that's it. Yeah.
Yeah. Okay, now I have a question. For example, if you take log of 100 at base 10, what's going to be the answer? So you can use this one. So look at this one here. And now think what is what actually. What is B? What is A? What is C? So we need to find C basically. We need to find C. So now look at this one here. Can somebody find it?
It's 10.
Okay, so let's just think like logically. So what is 10 if we look at the general equation? So we have this general equation here, okay? So what is 10 in case of A, B, C? Which one is 10 here?
A.
A, right. What is this 100?
B.
B, right? So we can write, so now look at this one here. So we can write like this way, 100 equals to 10 in power something, right? C.
Yeah.
So now you need to find this C.
2, I think.
Of course, it's going to be 2.
2, yes.
Okay, it's going to be 2. Another example. Now, let's just do like this way. So you have log of 10. This is X. We don't know this one. Is minus 3. So now find what's going to be X.
Minus 13.
Say it again, please. I didn't hear you. Can you say it again?
1,000. Minus 1,000?
No.
0.001.
Yes, right. So it's gonna be it's gonna be X is gonna be 10 in power minus 3. Okay, it's gonna be 0.001. Okay. So I want you to refresh this knowledge because you really need to know this to understand what is pH. Okay, and yeah, it's important. Okay, so this is about logarithm, but now I need to tell you what is pH. So pH is negative log. It says over here, it's negative log of concentration of hydrogen ions. Okay, so this is what is pH over here. So when you measure the pH, it measures the concentration of H plus. Okay, when you do something with pH meter, for example, or by the way, we'll have a lab about this pH. After the first lab, we'll have the second lab, and that one will be about this pH. So this is the minus log of H plus. So if we say practice a little bit, it's gonna be like this. Say what's gonna be the pH if we have something like this? Say we calculate it, and so say like that way. So we have log of 0.001 on base 10. We said that this is -3, right? Right. So
Yeah.
what's gonna be the pH in this case? How do you think?
3.
Yeah, exactly. It's gonna be 3. Yeah, it's gonna be 3. Because we got -3, right? So then it says that pH is minus log of something, and then of concentration of hydrogen. So it's going to be pH 3. Now please read here. So P function, the negative common logarithm of some variable. So it means that Px is the same as minus log x. So you might see pH, or you might see POH, or whatever P with something, it means that it's minus log of that something. Okay. Now let's just look some.
Excuse me, lecturer.
Yeah.
What's the P? You said P function.
So that's the P function. So that's just function. It's just indication of the function. Okay. So
function, okay.
anything which stands with P, it means that it's going to be minus log of something.
Okay.
All right. I don't know where it comes from, particularly this letter P. I really don't know, but the explanation is like that. Okay, say we know concentration, right? Okay, about the concentration, we can find the pH, but say we know the pH, how to find concentration? Say we know the pH, and we are given that pH is 2. How do you think, how to find concentration of H plus ions?
So it's mole per liter. It's mole per liter, and with this equation we can find this concentration with molar mass and molarity.
No.
It's
Forget
10,
about, yeah.
10 minus 2.
minus 2, yes.
Right, exactly. So the concentration is going to be 10
Minus 2.
minus 2. Yeah, exactly. This is going to be the concentration of H plus because the pH is 2. So you basically look at this equation here. So you take the minus pH, so you have pH 2, right? And then you take
Right.
minus pH to get the concentration of H plus. Okay. Now let's just Is it clear for everybody?
Yeah,
Yes,
yeah.
I
Yes,
think.
okay.
All right. So now let's just look at when the solution is basic or neutral or acidic. The basic solution when you have pH less than 10 to minus 7. So if you have pH less than 10 to minus 7, it's going to be basic. Okay. So neutral is when the neutral is the solution, the concentration of H plus is the same as 10 to minus 7. It means that pH is 7. Okay. So that's the neutral solution. When the concentration of H plus is 10 to minus 7 moles per liter, which means that pH is 7, which means that what's going to be the amount of hydroxyl ions there? How do you think? So, okay, concentration of H plus is 10 to minus 7. What's going to be the concentration of OH minus?
10 to minus 7 also.
Exactly. It's going to be 10 to minus 7 as well. So, and then POH is going to be 7 as well. So if you have acidic solution, it means that concentration of H plus is more than 10 to minus 7. Okay, moles per liter, which means that pH is going to be less than 7.
Less than 7, yes.
Okay, so if we have less than 7 pH, it means that the environment is acidic and the concentration is going to be more than 10 to minus 7 moles per liter. All right. Okay, now I have a question now. Say if I have concentration 10 to minus 6. So is this more than 10 to minus 7 or less than 10 to minus 7?
Less, it is acidic.
It's
Oh, it's small.
Yeah, so I'm asking about concentration. So it's more than 10 to minus 7.
Oh,
10 to minus
yes.
6 as a number is more than 10 to minus 7, right? It's 10 times more, right? So now, because of this, what we can write down is that so we have logarithmic expression for pH and POH, right? And eventually what we can write down is minus log of H plus minus log of OH minus is 14. So you need to remember that pH plus POH is 14. This is also constant. All the time it's going to be 14. It will never change. So pH of environment plus POH of the same environment is going to be 14 always. Now I have a question. If pH, say pH is 9, what's going to be POH?
6.
Why 6?
5.
Yeah, it's going to be 5, right?
5.
Because 9 plus 5 is 14. Now I have a question. Is this environment acidic or basic?
Acidic.
Acidic. Why do you think so that it's acidic?
No, it's basic because the pH is more than 7.
Right, so it's going to be basic, right? Because pH is more than 7. So it says over here. So if you have pH more than 7, it's going to be basic, right? And if
Right.
POH is less than 7, if
That's
POH,
basic.
right, exactly, it's going to be then basic. Yeah. Okay, so there is just some example here. So for swimming pool, which contains about 100,000 liter of water, you would have to add only 0.1 moles of HCl. It's 3.7 grams. See, very small amount, 3.7 grams to lower the pH of the pool from 7 to 6. So you can change 10 times the concentration of H plus, but you would have to add 10,000 moles, which is 370 kilograms of HCl to change it from 7 to 1. Okay, So it means that if you really want to make it acidic, because you will not feel this 6. Because, for example, if you put water, for example, you know what is the pH of Coke? Do you guys drink Coke? Coca-Cola, you know Coca-Cola?
Yeah.
Yeah, so do you know what is pH?
It's acidic, maybe, yeah?
Yeah, it is very acidic. Yeah, but you don't feel that much, right? So to feel this really acidic environment, you need really to decrease the pH about 1. So to do so, you need to put like 370 kilograms, like almost half a ton of HCl in a pool. Okay, otherwise, just small amount of that will not keep. I mean, why it's like that? Because it's logarithmic relationship. Because of logarithmic relationship, this is why this must be such a big change. Okay, so yeah, this is about, we talked about this one basically here. This is just how to measure pH. Very simple way is to use a paper and measure it. But how to do it exactly, you need to use a pH meter. This is a pH meter. We'll be using pH meter to measure the pH of the solution. Yeah, so this is about pH of body fluids. And you can see here that blood plasma, 7.4 pH. That's the normal pH we have. A little bit basic, just a little bit, it's 7.4. Interstitial fluid also 7.4. Okay, cytosol 7. Saliva is really changing. I guess it's from person to person, or depending on the, you know, what we eat maybe. It's 5.8 to 7.1.
It's sometime acid and sometime
Right.
basic.
Yeah, so the range is quite wide. Yeah, because you know what? Because saliva, basically, we'll talk a little bit about that. Saliva neutralizes the environment in the mouth. Okay, so because of that, environment might be sometimes
Yes.
basic, sometimes acidic. So depending on what is environment in the mouth, because depending what you eat, right?
Yes.
Or for example, what is happening in the stomach or anything like this. So saliva needs to react on that, and it might be basic, it might be acidic. Yeah.
Yes, but it's weak acid.
Yeah,
basic.
right. It's weak acid, definitely. It's not basic, actually, it's neutral. It's 7.1, it's basically neutral. Yeah, strictly speaking, it's a little bit as basic, but it's most neutral. But 5.8, it's a weak acidic, yes. But
Yes.
gastric juice is very acidic. See here, it's very acidic. 1.6, 1.8. It's very acidic, and it needs to be acidic because otherwise the product cannot be degraded in there. So because you know there's so many proteins coming in, many stuff, and you need to degrade this one, right? Then there is pancreatic juice. It's a little bit basic. Urine is acidic. Okay, and sweat is also a little bit acidic, right? Okay, yes, this is just a product, you know, you can look at that one, and these green products are more basic. So it says alkaline is the same, like, you know, alkaline means like basic. And you can see this, you know, these broccolis and all these avocados and this stuff. These are like considered as more like healthy. No, I would not say healthy food, but it's, you know, it's more basic food, right? Because acidic food also can be healthy. I mean, if you take not too much, it's also fine, right? But acidic products, like more dairy products, are more acidic, a little bit acidic. Meat is acidic. Yeah, so of course these beverages are acidic, and this, you know, all this refined sugar stuff like this, these are acidic. This is just a pH scale of some common substances, and you can see here that Sodium hydroxide is pH is high. Baking soda pH is like here. By the way, baking soda is really kind of buffer. Blood is also like we already talked about blood. Milk is a little bit acidic. Black coffee is quite acidic. Okay, of course vinegar is acidic. Lemon juice, of course, it's acidic, right? The stomach juice is even less than 2. Okay, and of course battery acid, you guys know batteries, right, which are in the car. So batteries, lead acid batteries, of course it's very acidic. All right, so buffer solutions. Any questions about pH and stuff like this?
No, I don't have any question.
All right.
Oh, thank you.
Okay, so about buffer solutions, it's very, very important concept, buffer solutions, because, for example, our blood is basically buffer. Okay, what is this buffer solution? Buffer solution is a solution which contains weak acid or weak base and its salt. Basically, it's conjugate. So we need to have weak acid and its conjugate. Okay, for example, if you look here, we have acetic acid and sodium acetate. So this is acetic acid, this is sodium acetate, right? So this is acetate, this is acetic acid. So what we discussed, right? So this is weak acid. Acetic acid is a weak acid. Okay, and its conjugate is going to be salt of this produced from acetic acid, which is sodium acetate. Okay, so this is going to be conjugate base acid base pair, which basically makes buffer. So there is a buffering capacity, so-called buffering capacity, because so what this buffer is created for? So buffer is working to neutralize the environment. Say for some reason pH goes from 7.4 to, I don't know, 6.5, right? So then buffer comes in and buffer pulls pH back to 7.4. So basically buffer neutralizes environment, because you can imagine that so many things are going to the organism, right? And they bring their own pH. And if each and every object changes or compound changes the pH of organisms, it will be just massive there, right? So because some functions of the some functions in the organism goes under the certain pH, so that certain pH must be always kept. Okay, so because of that, buffer is very, very important in the organism, right? So how does it work? And buffer has a capacity, right? Because it can say, I mean, it can neutralize small amount of acid, right? Say we ate something, say we drink Coke, which is a little bit acidic, but we have buffer and it can neutralize this Coke, acidity of Coke. But say, you know, if somebody drinks like HCl, right? So it's impossible to, this is why it's dangerous, right? So because too much amount of acid can hurt and even make some fatal consequences to the organism. So because buffer has capacity, it cannot take more than it can take, right? So how does it work actually? So look at this this equation and this equation. Say we put some acid in the environment, right? So acid means that we put some hydrogen ion, right? So then acetate comes in and neutralizes this hydrogen ion and producing acetic acid. So this is the part of the buffer, right? For example, if we put a little bit OH minus, which means that we made environment basic, right? Then acetic acid comes in and neutralizes this OH minus. How? It means acetate and water. So see acetate here? Basically, and water. Water is harmless, right? Water doesn't do anything wrong. So basically what we are doing that by having acetate and acetic acid, we can manipulate with acid and base. Okay.
Okay.
All right. So how to prepare buffer solution? By the way, this is what you need to do in the second lab. So you'll prepare buffer solution. All right. So how to prepare buffer solution? What we need to know is Ka. Usually it's provided. Okay. What is Ka in our particular case for acetic acid to sodium acetates? Again, this is the ratio of products to the initial compound. Say this is a ratio of ions of acetate H plus over acetic acid. So from here you can calculate H plus, for example. If you know Ka, you can calculate H plus. But how to prepare the buffer solution? Let's just look at this equation here. If we want to prepare buffer solution with particular pH, because buffer solution can have different pH, how can we change the pH of buffer solution? We can change the concentrations of these two, ratio of these concentrations. Okay, we can make this one higher, this one lower, and we can change pH. It's also important because sometimes you need to prepare particular pH of buffer, because for some environment that pH is good, another pH is good for another environment. So you need to manipulate with concentrations of conjugate acid base. Okay, so then it's easy to prepare. For example, if you know what is the concentration of buffer you want to prepare, you just calculate these two. I have less than 1 minute, but please come back when it's off, because I want to finish this concept. And if you know pKa, okay, then you can calculate pH, right? So pKa is the same as minus log of Ka. We discussed, right? Already Px is minus log x minus log x. There's the same thing is here. So pKa is minus log of Ka. Okay. So then in general, this is called Henderson-Hasselbalch equation. All right. And the general expression is like this one: pKa plus log A, log conjugate base over conjugate acid. Okay, do you guys understand? For example, this is conjugate